was going to say, Dr. Jensen, for someone that doesn't talk a lot, you sure talk a lot.
I knew I was going to get dinged on that.
So point 3 now, that somebody asked about this morning, we're finally getting there, is to monitor and treat animals selectively. So we talk about targeted treatments. That's the phrase that tends to get used in the literature. And what does that mean? It means we only treat the group of animals when they need it. We don't treat them just because it's July the 13th, or it's, you know, it's breeding time, or it's weaning time, or whatever. We treat them, or shearing time, we only treat them when they actually need it. And how do we know when they need it? We monitor them. And so fecal egg counts, like Dr. Peregrine talked about this morning, or clinical changes, or in combination, ideally, it will tell us when it's important to treat the group. So, when do we monitor and possibly treat the group? Because we're going to, based on the results of our monitoring, that's when we make the decision whether or not to treat. So when are we going to monitor the group? So one of the most common times that, and we've talked several times about the periparturient egg rise, is that we may want to monitor ewes and does prior to birthing. And so based on some research that Lara and our group have done, we looked at the periparturient egg rise both in season and out of season. And 50% of you said you lamb or kid out of season, so this is of particular importance. So we always think of the periparturient egg rise, and almost all the research in the world has been done in spring lambing or kidding. So it's spring, and they're also lambing or kidding, and that's when we see these really dramatic periparturient egg rise increases, which then serve to contaminate the pasture, and then those parasites are lying around waiting to infect the naive lambs and kids. We also, from our research, know that a similar contamination occurs in the winter. So if they're in the barn and you're composting the manure and so on, probably not a big consequence. If the animals are in a yard, or there's runoff from the yard into a pasture, then that could be important. So in the fall, what Dr. Falzon found was quite different. That ewes, in this, we only looked at sheep in this particular project, but when ewes in the fall were sampled, the egg counts actually fell after lambing. And that was probably because the seasonal need for those parasites to not waste energy producing eggs somehow overcame that need to contaminate the pasture. So in the fall, it is quite possible that when you monitor ewes at lambing or after lambing, you might find very low egg counts. So what is the periparturient egg rise? Just to review, it occurs usually about 2 weeks prior to lambing or kidding until about 8 weeks after, or when the lambs or kids are weaned. So that's the time period we're thinking of. So another time to monitor, lambs and kids at midsummer. And what is midsummer? Seems to change every year. We're getting close to it now, I think. And so traditionally, and what traditionally means, this is what we tend to see here in Ontario, but every year is going to be different. It's usually early to mid-July that we start to see enough build-up in the animals that we may start to need to deworm. So with the anthelmintic resistance project, when we were asking producers to send us in fecal samples once a month or more frequently, the first year we did it, we didn't start to see increases in fecal egg counts until late July and August. Last year we saw on some farms even in June, right, Lara? We found so it varies from year to year, and it's going to vary from farm to farm. And that's why it's important for you to know what's going on in your farm and to put it together with how warm and how humid it is. So if you had a problem the previous year in mid-July, you start to monitor a few weeks before that. So again, I can't give you a certain recipe, but I'm giving you information so that you and your veterinarian can develop a plan. So repeat monitoring during the grazing season. So if the counts are low, repeat in 3 to 4 weeks to monitor again. If the counts are moderate, you may want to repeat in 2 weeks. We know Haemonchus is an incredibly prolific egg producer, and they can go from nothing on the pasture in the spring to incredibly heavy loads by mid-July. So because it's such a pathogenic parasite, we may not want to wait too long before we take fecal egg counts again. Monitor after treatment. So if you've done a treatment with an anthelmintic, then usually we don't need, and we believe it's effective, we would do a fecal egg count between 4 to 6 weeks after treatment. But if you see clinical signs after your treatment, that is, you suspect there's treatment failure, then it's 2 weeks, and Lara will talk about that again. But that's that, you got to wait that 2 weeks so we make sure that the parasites we just made sick but didn't kill are back to producing eggs again, so we can pick them up, but not waiting so long that we're picking up new infections. Should you monitor in the autumn? So as I mentioned before, parasites kind of go to sleep. Those L4, instead of turning into adults, they go to sleep. And they wait until spring before they start producing lots of eggs. So the process actually starts amazingly in late August. Again, that may be seasonally affected, and it might have something to do with the health of the animals as well. But it's pretty well complete by October. So you can have a heavily parasitized kid, for example, and you take a fecal egg count at Halloween, and it might be really low, and it may not reflect the parasite load in that animal at all. So doing fecal egg counts in the autumn, particularly later in the autumn, may not be very useful to you because you can't tell whether they're parasitized or not. Should you treat in the autumn? So Dr. Jansen talked about how effective some of the anthelmintic drugs are against these inhibited larvae or arrested larvae. And yes, they will kill those in the fall. So, and the idea is that maybe they will also prevent the periparturient egg rise when they lamb in the winter and spring, We are just completing a trial now to look at the efficacy, but we don't have the results yet, or at least I haven't seen it. Okay, Lara's shaking her head. No, we don't have the results. But that work has been done on some farms here in Ontario, and 3 different farms that are on accelerated lambing systems, and we are just finishing up the last of the samples in the spring. So these are ewes that were treated back last fall, and we're seeing whether or not it actually works. Because it's one thing for me to tell you, oh yeah, it works great, but it's another thing to actually prove whether or not it works. Should you treat pre-breeding? Generally, adults don't need to be dewormed because they have good immunity. So, I mean, obviously the exception is if you have elevated fecal egg counts or there's clinical evidence of disease, then you may decide to deworm. But it's not a routine procedure that you would do. So treating pre-breeding may be totally unnecessary, and any unnecessary treatment could increase the risk of anthelmintic resistance. Okay, so we've talked about targeted treatment of the group, right? So you're treating the lambing ewes, you're treating all the weaned kids. These are of the group. But now we're going to talk about treating individuals. And so targeted selective treatment means treating those individual animals that need it when they need it. And so even if the fecal egg count on the pooled samples are high, we know that there's a fairly significant proportion, probably within the group, that don't require treating. We talk about this 30-70 rule, that 30% of the animals are responsible for 70% of the egg shedding, which means 70% of the animals are producing 30%. So we want to catch the ones that are shedding lots, the few animals that are shedding lots. The trick is, how do you find them? And one of the phrases that gets used in South Africa is leave the best and treat the rest. That's the goal. We want to leave the best and treat the rest. So how do we determine which animals are the rest? So fecal egg counts is excellent, except nobody can afford to do individual fecal egg counts. And then if you have a couple of hundred lambs, you're not going to do individual fecal egg counts. It's just impossible. Even if you're really, really good and efficient and awesome, even if you do it yourself, it's going to be horrendously expensive. So pooled fecal egg counts are very valuable in knowing when the groups within the flock or herd should be dewormed. But they're not very useful in determining which animals within the group should be dewormed. If you have 5 animals, that's a difference. But if you've got 500, of course, this isn't accessible. So going back to the phomagen. Again, it's limited to Homunculus, which at this point is not the only parasite, but it seems to be the worst parasite. Make sure that when you use it, you record everything that you do. That's critical to having the FAMACHA program work. So when you decide whether they're a 5 or a 1 or a 3 or a 4 or a 2, you need to record them, okay? And in the envelope that you'll get when you hand in your evaluation forms at the end of the day is an example form that you can photocopy, or you can make up your own, or you can put it into a spreadsheet, because we're all awesome at Excel now. So this is the form that is used comes with the FAMACHA chart. So here, across here is a treatment, when you looked at the app. So you'd say, here it is, it's May 1st, and I'm going to examine all the lambs or all the kids in this group. And so here's 1, 2, 3, 4, 5. And if you remember, 5 is almost ready to keel over dead on you when you go to catch them, and 1 and 2s are perfectly healthy animals. So in this, on May 1st, they scored these animals, and they found that most of them fell into the 1 and 2 category, and some of them fell into the 3, and they had 1 in 4, and because they recommend treating the 4s, that animal was treated. 2 weeks later, they scored them again, and you can see they're starting to get a shift down to anemia. Now this example came 15th, we should be seeing that, but so they started treating more, and then 2 weeks later, at the beginning of June, they're starting to treat more. So this is a way of keeping records easily, very low tech again, which is really important, to track what they actually have done. Now individual animals, IDs are not recorded there, and I'll come to that in a second. So again, these are treatment guidelines. Treat goats and sheep that are in category 4 and 5. They're the ones that are clinically anemic. Use an effective anthelmintic. So if you aren't sure whether ivermectin is working on your farm, don't use it. Use something which is known to be effective. So that's fenbendazole. If you're concerned that they might only be partly working, then we're talking about this, like treating fenbendazole, not at double the dose, but treating them twice 12 hours apart. So that will, for parasites that are heterozygous resistant, that Lara talked about this morning, that will be more effective in killing those. Don't use it in isolation. Always use pooled fecal egg counts to also monitor, because we don't want to get losses from telangiectasia when we're so busy trying to kill homuncus. Use other techniques like evasive grazing that Anita talked about, and of course only treat those animals that need it. So we're talking about the targeted selective treatments. So if there is no animals in category 4 or 5, don't treat them. Just re-examine them 2 weeks later. You have to do them every 2 weeks. Again, you have to know your farm and know how quickly you can get into trouble. So Southeast U.S. is where this is used most commonly, where flock sizes tend to be really small, and they tend to do it every 2 weeks. If it's cool, then if it's like, 15 degrees centigrade out there and we've got a really nasty cold spring, you're not going to maybe have to do it as often. If it's 25 to 30 out there, those homuncus can go from eggs to L3 in less than a week, and you better be out there doing that every 2 weeks, because we know homuncus produce thousands and thousands of eggs a day, and it doesn't take very many homuncus, only 1,500 in the abomasum, to kill them. But the last 2 bullet points are really important. Gain experience, be careful. If you have less than 10% category 4 or 5, then just treat the 4 or 5s and re-examine 2 weeks later. If you have greater than 10% in 4 or 5, you may want to consider treating 3s as well. Remember, I talked about the inaccuracies of the program and how sometimes 3s are actually really anemic. So this way you're being careful. You're not allowing those 3s to die in a week of anemia because you've misconstrued, or they're on such an increase in the loads out on pasture. Change pastures if possible, because maybe that pasture is heavily contaminated with homuncus. But again, going back to what Lara said, don't treat and then move. You got to treat, leave them there for a few days before you move. And then consider, if you've got a lot of 4s and 5s, consider maybe treating them, checking them more frequently than that. So recommending to treat 3s when greater than 10% are in category 4 or 5. If the group are young animals, so we know they don't have any natural immunity, so those animals are going to be much more susceptible. Sometimes it's around kidding or lambing, and those ewes or does may maybe their immunity is suppressed because they're stressed about lambing or kidding or lactating. If they're already thin for another reason, if you're down to one effective drug, consider using the less effective drugs in the category 3 animals and keep the more effective drugs for the 4 or 5. It's important to integrate this FAMACHA system into everything else you do. So that means you know, using other clinical signs to pick up animals that seem sick, animals with bottle jaw, maybe animals with diarrhea and so on. Okay, so that particular record didn't have you recording ear tags. And understanding that everybody has perfect identification in all their animals, which are clearly legible from 20 meters at least. So because you know, sometimes animals lose ear tags or they're not readable easily, then in the package you'll get, there's a whole bunch of different methods of trying to identify treated animals. And why is that important? Well, I'll get to that in a minute. So ear notching, wire through the ear tag, paint markers, cable ties on the legs. These are all things that are recommended to identify animals that you've had to treat because they failed the FAMACHA score or some other clinical sign. They've needed treatment. Precautions. So the precautions are, and you've heard me say them again and again, you got to be trained. So that's what today is about. It's only an aid. It's not the end point. You have to integrate it. And so it's a component of the whole 5-star program. And you should work with your flock veterinarian or your herd veterinarian to integrate it into your entire program. So again, just to review, there are other clinical signs: diarrhea, weight gain, body condition score, and there has been, so I don't know if there's anybody here milking sheep or goats? Mostly adult sheep. Again, we don't see clinical disease in them, but with dairy goats are a real problem because, first of all, goats don't develop immunity as well as sheep do, so we can get clinical parasitism in adult dairy goats, and then if we have to go treat them, then we have to withhold that milk. And what's the withhold, Jocelyn, on fenbendazole in dairy goats? Is it 5 days?
Yes, 5 or 6 days.
Yeah, so there's a lot of, not only do you have the lost production because of the parasites, you have the lost production because you've got to toss the milk for quite a length of time. So some producers have decided, I'm not going to pasture my adult dairy goats, my lactating dairy goats, because of the issues around them. And they have also seen that if you were doing individual milk weights, then parasites will really suppress milk production. And in some parts of the world where they pasture their dairy animals, they will use that as a method of identifying animals to be treated. Keeping in mind, you've got to toss the milk for quite a while. So I want to underline this periprotein egg rise issue. So we know not all ewes and does have a significant periprotein egg rise. It is connected to some things, and what it's connected to is number of lambs or kids that are nursing. So those that are nursing singles tend to often not be that stressed versus those that have twins or triplets. And depending on your nutrition, it could be the difference between singles and twins and those nursing triplets. If they're young, if they don't have a lot of immunity, some people don't pasture their lambs, so that ewe lamb or doeling, that first year pasture, that's when they pick up the infection. And so age may have has an impact on how much that periprotein egg rise is. So if they had a big heavy load last fall, they're going to really express that load in the periprotein egg rise in the spring. Other disease. Unfortunately, we know that there's a lot of Johne's disease out there, particularly, hate to say it, in the goat world. And Johne's, in one of the ways it may manifest is these animals have a weakened immune system and they shed more parasite eggs. So having Johne's in the flock may increase the number of eggs shed. Okay, so you've heard this a number of times today. Telodrosacea and trichostrongyles have absolutely no problem overwintering on pasture in our climates. It doesn't matter about freeze thaws. They seem to be particularly, the L3 have this little capsule around, they seem to be particularly able to survive even the nastiest freeze thaws. through our winters. Bad news. The good news, sort of, is that Homunculus, because it's originally a tropical parasite, doesn't overwinter on pasture in our climate very well. You never say never, but we might find the larvae out there in the spring, but they seem really sick and they don't seem to be able to establish an effective infection. So the pastures are not, so getting back to Lara's conversation about refugia, in the spring you can essentially no Homunculus refugia. There might be lots of Teledrossasia, lots of Trichostrongyles, but there's no Homunculus refugia out there on the pasture. The only refugia for Homunculus is in the sheep or the goat. And that's very important to remember. So they only can overwinter in our climate inside the animal. So that's great. We think, well, then we can eradicate them. Well, obviously that didn't work. So how does a pasture get contaminated? It's these Parapatorian egg rise from the ewes and does. They go out and they put the eggs back on pasture, and that starts the cycle again. So if we can eliminate the PPER, then maybe we can eliminate Homunculus problems, right? But if we deworm everybody, then what's left? Because again, looking at the genetics, within a population of parasites, let's say an unselected population of parasites, we might have 100 Homunculus, and 99 are susceptible, and 1 is carrying those resistant genes. We kill the 99, and only the 1, well, he has to have a partner to mate with, but the 2 get together and they have babies, and their babies are all resistant. And so that's what survives to contaminate the pasture. In the first year, there's so few they don't get going. Second year, maybe a little bit more, but you don't see disease. Third year, absolute disaster, and that's when you treat and the animals start to die. So we see anthelmintic resistance, and so maybe the only time you deworm is at lambing. And you say, well, I hardly use any anthelmintic. How can I have resistance? And there's the reason. You can get resistance to Homunculus if you deworm everybody and there's no refugia. So it comes back to we need to keep a low level of refugia, but we can't deworm everybody so we don't create resistance. And we wonder if that's what's happening here in Ontario. And we're primarily seeing resistance to Homunculus. So timing of treating and moving pastures, this is just to underline the point that Lara made this morning, that dose and move, also it's the same idea as what I just talked about, that if you deworm them and move them to a clean or safe pasture with no or very, very few parasites on it, the only ones that serve to live to mate and contaminate the pasture are the resistance ones. And it doesn't happen in 1 year. It usually takes several years of the same kind of practice, and you will end up with resistance, even with very little deworming. So now the research has shown that we want the delayed dose and move, so that you leave them on the contaminated pasture for a few days so they pick up some susceptible new L3, and so they have a mixed infection in there. So it slows it. Doesn't eliminate the development of anthelmintic resistance, but it does slow it. So this was developed in South Africa for internal parasites. And it brings together a lot of the points that we've discussed. So using FAMACHA, using body condition score, or I think I prefer the weight gain if we can work towards introducing that. DAG scores for diarrhea, bottle jaw, and for the South Africa they've also included nose spots. So we have, again, it's about using everything together. And of course fecal egg counts. So briefly I'm going to talk about some of the alternative methods that are evidence-based, for which the research that's in the literature shows that there's a benefit. Some of them we can use, some of them we can't. But there's always a lot of discussion on the internet or in meetings and so on about what works and what doesn't. So and there's a bit in the handbook for you to read as well, so I'm going to go through this fairly briefly. A couple of years ago, one of our former graduate students, Dr. America Medeiros, did a review of all the literature on any alternative method. Now, alternative methods are good because it can reduce maybe our reliance on chemical anthelmintics, which is always good. But we want to make sure whatever we do is effective, because if it's not effective, then we can get into worse problems. And not only is that an animal productivity issue, it's an animal welfare issue. So there's been a lot of really good research done on condensed hen and pasture plants. And so these are plants that are high in condensed tannins, which act on the parasite in two ways. One of them is they can serve as a source of bypass protein, so that improves the immunity, but it also seems to have a direct action on the parasite. So almost all the research has been done in this tropical one, which is Sericae lepidisa, or everybody says lepidisa. This doesn't grow in our climate. This is the one that really grows in our climate, but it has lower levels of condensed tannins. So is it useful to put bird's foot trefoil in your pastures? Perhaps. Is it the only thing you need to do? Absolutely not. But it may help to reduce it. Genetic resistance. So there's been a lot of work done in New Zealand and Australia on genetic resistance, and how they've done that is they've taken a large population of animals, they looked at how many eggs they produce or how many antibodies they develop against them. They're using a Carla's saliva test, which we looked at trying to get, but they're not willing to run in here in North America. We've asked them a few times. So being able to walk up to an animal and test the saliva for antibodies. So the idea is that you want animals that develop their immunity faster than the other animals in the group, and therefore have lower egg shedding. The heritability is moderate, but over time you can improve the heritability within your flock or herd. Well, all this work has been done on sheep, I should say. So the research was done when they have, 100, 200 rams all out on the same pasture with the same exposures. Well, we don't have farms like that here. So it's difficult for us to do it. There are breeds out there that have maybe naturally develop resistance faster, and some of those may be the more tropical hare breeds. But they got to have the right economic traits for you to put them into your pasture system. There has been some work done on gene tests. There's one called Wormstar in New Zealand, but it's looking for single gene, and these things are often more complicated than that. They use more than one gene. So we're not there yet on that. So what's something you can do, and you can do it this summer, and it's low tech, and all it does is require records of treatment. Then instead of looking for the animals that develop resistance more rapidly, you get rid of the animals that are slower. The animals that need to be treated more often, or that have higher fecal egg counts if you're doing individuals. So get rid of those guys, put them on the cull list, market the offspring, don't retain them as breeding stock. So get rid of the bottom and instead of looking for the top. And that's something you don't need any fancy tests to do. Just good records. Yes. Some of the others we don't have access to, Nematophagus fungi, which worked really well. Copper oxide wire particles. I want to say this about them, that the work was done in southeast US, and it's somewhat effective against only homuncus. Temporarily reduces the fecal egg count, doesn't seem to improve weight gains, doesn't seem to work as well in goats as in sheep. It's not that it doesn't work at all. There are some issues around them. First of all, it is copper oxide and not copper sulfate. We've had a few cases of people using copper sulfate and killing their animals, large numbers of animals, so that's why I'm making the point, because it is happening out there. The data that's been at least published on the copper levels of sheep that have had these copper oxide is they do have elevated copper levels. So I do use that caution that if you're going to use them, you better do some slaughterhouse monitoring of the copper levels to make sure you're not causing more damage than good. There's lots of other natural dewormers out there. We could not find any scientific evidence that they worked. Some evidence that they didn't work, and some there just wasn't any evidence at all in the literature. And so I guess you can say, well, I'm going to use this and I'm going to use that, and it works really well, but the fact is there's no scientific evidence that works. And all I want to do is underline that whatever you use, it must be effective, or it could be part of the problem. Okay. So while we're setting up, yes?
How quickly do you see, if you deworm or worse, how quickly do you see the anemia start to
So the question was, after you deworm, how quickly is the animal going to get better?
doing that test.
Well, within 2 weeks, you should start to see an improvement. And it depends on a lot of things, like how bad were they? how close to death. It might take them a little longer. And is there any other disease that's knocking them back? So, but you should start to see an improvement in 2 weeks.
Would you recommend giving something kind of boost up?
Just a good balanced nutrition, access to mineral. Don't, well, what vitamin would you give them?
New cells.
New cells?
Yeah.
Okay. I don't know. Okay.
The B vitamins, because
One other, yes.
B12.
It was recommended that the FAMACIA testing be done outdoors.
Yes.
Most handling systems are indoors.
I know.
Could you use the natural lighting light bulbs? Is that more effective? Because you can get.
So the question is, if your handling system is indoors, and I'm just told you you've got to take the FAMACIA cards outdoors, would natural lighting lights work?
Light bulbs, yeah.
And I can't answer that question because I've never used those and I don't know how bright they are and they're not sunlight. But it just underlines the point that if you're going to use them, you can't have colored light bulbs or yellow light bulbs. So that's a good point and I don't know the answer to that. Sorry. But you know what you could do is the Southern Consortium, maybe they've answered that on that particular webpage.
We use the FAMACIA, and I find if you do it under the same lighting all the time, that you're gonna get a feel for, the different levels of the like the red, pink, white.
Also with the same person.
Okay, so the point was that if the same person uses it all the time, and then at least they're either just as correct as they were before, they're just as wrong. But it's working for you, and so you will learn from your mistakes for sure. It won't prevent you from over-treating, but it might prevent you from under-treating. Yeah, good point. Do we have time for one more? There's one at the back.
If you selectively deworm half your ewes, can you use the other half as a refugia and not return them after worming for a day or two to pasture? Or should you also return to the pasture to pick up some of the susceptible?
Yeah, okay, so that's a very good question. And no, I think the animals you're most concerned about are the animals you've treated. So, I think that everybody heard what he said is that the animals you don't treat, do you need to leave them on the pasture to get reinfected? And no, because they already have the susceptible parasites still in them. Okay, and you brought up an interesting point that when you say, well, what proportion of the group is sufficient to leave in order to slow anthelmintic resistance? And what the Southern Consortium says is that you should be leaving at least 30%. So if you're treating more than 70% of your animals, then that could lead to anthelmintic resistance. Now, if you've got more than 70% that are 4s and 5s and 3s, you're in trouble, regardless. But you should be leaving at least 30% untreated so that you don't develop AR. And the higher the proportion, the even better. But again, keeping in mind you don't want animals dying. So that's a very good question. So I think just because we're really far behind, I guess we'll keep going. So all my questions are really easy. Dr. Peregrine told me that. They're just too simple. Well, thanks.
Oh, sorry.
Thank you.
Robert, yeah, you're getting trained.
So the first one is, which...
My apologies.
It's okay.
It's so sensitive, this thing.
Which of the following is the best approach for preventing periparturient egg rise as well as not promoting anthelmintic resistance? To treat all pregnant females in the fall, to treat all pregnant females prior to lambing or kidding, to treat females carrying multiples as well as any females showing clinical signs of parasitism. Okay, so the C is the correct answer, that we want to prevent the Paracriterian egg rise but not promote anthelmintic resistance. We only want to treat those females that are going to be at a higher risk of shedding large numbers of eggs, and those are the ones carrying multiples as well as any ones that may be showing signs of clinical parasitism. Okay? Monitoring lambs and kids for evidence of parasitism should be done, A, when processing for vaccination, B, early to mid-July, regardless of farm history, C, early to mid-July or earlier, depending on weather and farm history of parasites, D, 1 week after treating. Okay, so C is the correct answer, that early to mid-July or earlier depending on the weather and the farm history of parasites. And again, you know your farm. Yes?
The question before that, it had down there just to treat ones that were carrying multiples. Would you not, like, what would be the rule on treating like yearlings or 2-year-olds, the younger ones that are pregnant? Would you treat those to prevent
So
them?
yeah,
Because they're
and I mean, I
higher
didn't make a
risk.
long, sorry, the question is, would you treat yearlings? And that might be a group that you'd want to treat as well. I just didn't make a really long list. Sorry. You know, the vet students are expert at trying to figure out what the right answer is without knowing what the right answer is. And so if it's a really, really long answer, they pick that one because it must be the right one because I spent so long time writing it. So the last question is, for which of the following alternative methods of controlling or treating parasitism is there no scientific evidence for efficacy? A, diatomaceous earth for gastrointestinal nematodes. B, copper oxide wires for Haemonchus contortus. C, condensed tannin pasture plants for gastrointestinal nematodes. And D, selection for resistance using fecal egg counts and good records on ramps. Okay, so A is the correct answer. There's nothing in the scientific literature that shows that diatomaceous earth is effective against gastrointestinal nematodes.
You had it listed as dangerous.
Yes, so if you, diatomaceous earth, if you inhale it, is actually dangerous. Because I know it gets incorporated a lot into feed, and actually most of the literature out there is for use of controlling garden bugs, but people handling it have to be very careful because it can be inhaled and cause lung damage. Yeah. Okay. I think just 3. Yeah. Great. Thanks very much.